NENOMATICA, where mathematics meets YouTube excellence. Example: we will simplify a nested alternating sum of fifth roots by recognizing a geometric series structure. Problem: simplify the expression 1 divided by fifth root of 16 minus fifth root of 24 plus fifth root of 36 minus fifth root of 54 plus fifth root of 81. Step 1. Identify the geometric series parameters in the denominator. We will label them as AQ and N, the denominator alternate signs, and each term is the previous term multiplied by negative fifth root of 3 over 2. Step 2. Express the denominator s using the geometric series sum formula with n equal 5. Step 3. Compute q to the fifth power. Since q equals negative fifth root of 3 over 2, raising to the fifth removes the radical and preserves the negative sign, giving negative 3 over 2. Then q to the fifth minus 1 equals negative 5 over 2. Step 4. Substitute negative 5 over 2 into the s expression and simplify the signs by multiplying top and bottom by negative 1. Step 5. Rewrite the denominator as a single fraction with fifth roots of 2 and 3. Fifth root of 3 over 2 plus 1 equals fifth root of 3 plus fifth root of 2, all over fifth root of 2. Step 6. Substitute the rewrite into s and simplify. Multiply by fifth root of 2 to obtain fifth root of 32 in the numerator, which equals 2. Step 7. We have an exact closed form for the entire denominator. Step 8. The original expression is 1 divided by s, so invert the result. We obtain fifth root of 3 plus fifth root of 2 all over 5. Summary: we identified the denominator as a 5-term geometric series with first term fifth root of 16 and common ratio negative fifth root of 3 over 2. Using the series sum formula, we simplified to 5 over fifth root of 3 plus fifth root of 2. Inverting yielded the final answer, fifth root of 3 plus fifth root of 2 over 5. Practice spotting geometric series hidden inside radical sums. We will simplify a radical expression by spotting a geometric series pattern. First, the word example appears. Then we display the problem in bold, orange math. 1 over the sum of radicals. Define the denominator as the letter A. We use a helper variable definition. Now, we write A equals the full sum of radicals. Quick challenge. Can you guess why we introduce A? Recognize a geometric series. The rule is to identify first term, common ratio, and number of terms. Here the common ratio is the sixth root of 2, the first term is 1, and there are 6 terms. Apply the finite geometric series sum formula. We use A equals a times quantity q to the n minus 1 over q minus 1. Substituting at equals 1, q equals sixth root of 2, and n equals 6. This simplifies because the sixth power of the sixth root of 2 is 2. Simplify the original expression. Since the denominator equals A, 1 over the denominator is 1 over A. Taking the reciprocal gives the final simplified result, sixth root of 2 minus 1. Example: we will simplify the expression 1 divided by the sum of 6 radicals. Our goal is to recognize a geometric pattern inside the denominator, sum it cleanly, and then take the reciprocal to obtain a compact final form. Let's write the problem and name the denominator s, so the whole expression is 1 over s. Step 1. Rewrite each number with prime factors 2 and 3, so that fractional exponents become clear. 32 is 2 to the 5th. 768 is 2 to the 8th times 3. 24 is 2 cubed times 3. 432 is 2 to the 4th times 3 cubed. 18 is 2 times 3 squared. 243 is 3 to the 5th. Now, convert each radical into powers of 2 and 3. Step 2. Observe a repeating ratio. If we take the 12th root of 2 squared over 3, that is 2 to the 1/6 times 3 to the negative 1/12, and multiply by a term, we get the next term. Define R equals the 12th root of 4 over 3. Also notice that the last term, the 12th root of 243, is a convenient first term. Then our 6 terms are a 1, a 1r, a 1r squared, up to a 1r to the 5th, just in reverse order in the original sum. Step 3. Use the geometric series formula with 6 terms. The sum 1 plus r through r to the 5th equals r to the 6th minus 1 all over r minus 1. Therefore, s equals a 1 times r to the 6th minus 1 divided by r minus 1. Step 4. Compute r to the 6th. R is the 12th root of 4 over 3, so r to the 6th is the square root of 4 over 3, which is 2 over square root 3. Then r to the 6th minus 1 equals 2 over square root 3 minus 1, or 2 minus square root 3 over square root 3. Substitute a 1 equals the 12th root of 243, and simplify by dividing by square root 3. Step 5. Replace the factor square root 12th of 3 times the quantity square root 12th of 4 over 3 minus 1 by an equivalent difference. Multiply inside to obtain the 12th root of 4 minus the 12th root of 3, which is the 6th root of 2 minus the 12th root of 3. Hence south equals 2 minus square root 3 divided by the 6th root of 2 minus the 12th root of 3. Step 6. Our original expression is 1 over s. So 1 over s equals the 6th root of 2 minus the 12th root of 3, all over 2 minus square root 3. Rationalize by multiplying numerator and denominator by 2 plus square root 3. The denominator becomes 4 minus 3, which is 1. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.